Okay, so yesterday, this is the problem I did. If you don't remember the problem, it was this. It was y equals x squared minus 4x minus 1. We had the y equals negative x plus 3. This is what your assignment was on yesterday, remember that? You had to find those points of intersection where the parabola hit the line, right? And you had to figure out those points of intersection. That was what we did yesterday, right? Here's the idea. For the last 10 seconds of the problem, I said, okay, hey, let's go figure out where the Directrix would hit this line down the road. I thought it was weird that I pulled up my numbers, right, and I showed you all the digits and whatnot, and this number was way off compared to the one that I showed you guys in class. And I was like, oh, that's weird. I must have just typed in wrong or something. No, because I did a silly mistake. When I did the vertex and found the Directrix, did the vertex here, and found the Directrix, and then figure out where the Directrix and the line meet, I did it for the equation where these two were set equal to each other. That isn't that green Directrix. And I caught it when I later in the day, because I was publishing the video, and I'm like, huh. That dot was way off, and then I looked at the equation of my Directrix that was on the film. I was like, that wasn't the equation, because this thing, you can see it, like it's hitting like right around 5, and the Directrix I had written down on the marker board said like -8 something. I was like, oh, that's quite a bit off. And it's because you have to do the Directrix for this equation. And I totally didn't even catch it until I watched the film that I was going to publish. So let's do a quick fix here, just because I don't want to leave it off on a wrong note. So on this part, to do the Directrix, you have to move the 1 over. You have to do the completing the square process. I don't have to factor in anything. Half the middle squared is 2 squared, it's 4. Add that to both sides. This turns out to be a 5. This turns out to be an x minus 2 over here. So the actual vertex, the lowest point on this graph is 2 comma -5, which makes way more sense compared to the number I gave you in class. It was like my number that I gave you here was way different. And then we went, then you had to go down a 4th from there. So the Directrix is actually -5 and a 4th. Now, again, how I know it's a 4th at distance to the Directrix, again, this is the Directrix, because you always take the number that's in front of this parenthesis and you set it equal to 1 over 4c. Well, that just happened to be the same number that I gave you guys in class. It was a 1. You would multiply the c across, and that would just be a 1 times c is just c. So this is the distance out to that Directrix. And that was the number I had wrong. I had this vertex wrong yesterday, because I did it for the equation where I set these two equal to each other. That's where you had to figure out where the crossing points were. That wasn't the actual Directrix coordinate that I needed. So, yeah, that was my bad. So I thought we'd better fix that. And then again, what you do is you set this line right here, you set that thing equal, that should be a 3. You set this thing equal to the Directrix line, which is this one. You set those two equal to each other. And that was something I had written down wrong yesterday. I didn't even think about it. So -5.25 is equal to the -x plus 3. Right, you actually set them equal to each other. I would subtract the 3 across, that makes -8.25. And divide by -x, or -1 I should say, and I get a 8.25. And that's this coordinate over here. It's 8 1/4 over, and it's 5 1/4 down. How I know it's 5 1/4 down? Because it's hitting the Directrix. The Directrix is 5 1/4 down. And that was the number. I had it way off yesterday, because I did it for the equation where I set these two equal, and that's not the bowl. It's not the parabola. So that was my bad. So I had to make a quick fix. Didn't even think about it until I caught it on video when I was publishing it. I was like, that ain't right. So. Good fix. So period 9 had the right one. I caught it for you guys because I was publishing right after you guys left. So thought I better fix it today. All right, let's get to our new notes today. So you need notes. All we're going to do today is notes. That's all we're doing. You will have a Google question of the day today that you have to answer eventually. So I'm gonna wrap up the section 9.1 today. So we're gonna finish this. We're gonna finish the notes for 9.1, so you can kind of get it. You will have a Google question. It will go. I think it goes live in about. It probably went live about 2 minutes ago. That's going to be based on the new stuff we do today. So pay attention to that. Hopefully you get the notes written down for this stuff. Again, the problem you're seeing on the board, this is that fix from yesterday. I totally made a mistake from yesterday for those who walked in late. So, all right. But yeah, that was the fix. I didn't even think about it until I was posting video about the mistake I made on that one. All right, let's keep going here. All right, so new thing today. I'm gonna get rid of this stuff. All right. And just to prove that coordinate was the correct one. There you go. That was the number I showed you yesterday. I was like, oh, that's way up. Yeah, I didn't think about it. Did it for the wrong parabola. So, all right, we'll get rid of this stuff. We don't need this anymore. Okay. All right. Let's discuss our new thing today. I want to talk about parabolas, obviously. That's the section we're going to end section 9.1 today. It's the last part of it. I want to talk about what happens when you have a parabola that is turned on its side. So it is not a vertical parabola where it's going up and down, right? So a vertical parabola is where, it's something written like this, where you have your graph, you have your parabola going this way, you have your focus on the inside, you have your directrix down below it. I'll put the directrix as a dashed line. This is the directrix. That's the focus. And this is the vertex, right? That was a traditional one we've been doing for, the last 4 sections, something like that. The last 2 in the last test, and then obviously the one we started the other day. We need to do a horizontal one, where you turn it on its side, and it still does the same math. We're not going to go through all the process of figuring out where lines cross or anything. We've already done that stuff. You can do all the same. I just want to show you the formula, show you how to calculate stuff, how to calculate focus, how to calculate directrix with it. That's all I want to talk about today. So pretty easy. This will be pretty quick. I might do 1 or 2 of these, and then that'll be it today. Then I'll turn you loose in your Chromebook. You can go answer your Google question of the day today. But let's talk about a horizontal parabola today. So now the formula, how the formula is different. All they do is they switch the letters around. That's it. It's the only difference. It's the same mathematics, but you'll notice that the y's, there's more y's in your problem than x's. There's only going to be one x, and then the y's will be, there'll be a bunch of variables for the y's that you'll see in your problem. So I'll make up one here in a second. But all that does is it changes your parabola to be this. That's all it does. Changes your parabola so it's horizontal. And so the focus is on the inside, so this would be the focus now. So the focus is actually to the right of your vertex. This is the vertex dot. And then your directrix is this line going up and down. That's the directrix. Do you see the differences in drawing? Okay, quite a bit different. How we find the focus and directrix still the same. It's that 1/4c part. But just the overall general work is different. So that's what we're going to look at today. We're going to do 2 of these. That's what I want to do today. All right. Turn off that screen share. All right. Okay, so this is kind of our goal today. I want to talk about how to calculate this, how to find the focus, the directrix when it's turned on its side. Now the math would still be the same if you're going to figure out where lines cross. Same old, but I do want to talk about it. All right, so let's give me an example here. X is equal to y squared plus 10y minus 3. Okay, so this is one of my 2 examples. I can immediately tell this is horizontal because the variable that is squared is the y, not the x in this case. So that's kind of the idea. I remember very vividly in college, professors would, at least my calc professor that I had at the time, always struggled to know which way you had to draw the graph. I found that really weird. A college professor always struggled with that. Whatever variable is squared, you're going along the other axis. So I'm going along the x-axis. That's the idea. So you have to look at which one is given to you. I always found that really weird. So, but anyway. So now that we have this, this equation, I'm going to do the completing the square method just like before. I'm going to move any number over to the other side. So I'm going to move that -3 over. I'm going to leave this y squared alone. And then I'm going to complete the square on that. If there's any number out front, I'll have to factor it off. I'll do that in my next one. I'll factor off a leading number out front so we can see that example. But on this case, I don't have a leading number, so I don't have to worry about it. So half the middle, so what's half of 10? 5 squared? 25. And so we have to take that number times the number up front. Well, there's no number up front, so that's great. And we add that to the other side. So I'm going to add the 25 across. All right, so it's that number times the number out front. Again, when I put a leading coefficient out front, we'll look at how difficult that can get on the next one. Again, you might get decimals or whatever, that's fine. So it ends up being x plus 28 over here. And on this side, I'm going to factor this apart, so it's y plus 5 squared. So now I can read off where my vertex is. And again, I will graph this here in a second, so I'll probably turn on my projector again one more time. So we'll come back, we'll look at it. So the coordinate here, when you read off the vertex coordinate, and this is the part I don't want you to get wrong. The number that goes with x is over here, the number that goes with y is over here. So what number is with the x?
28.
Say it?
28.
Yeah, 28. We have to do the opposite of that number like always, so it's going to be a negative 28. Okay? Don't put them in the wrong spots. Find x, read off that number. What's the number with the y?
-5.
Exactly. You always have to read off the opposite number. So there's my vertex. Yeah, I'll graph it here in a second. I'll throw it through Desmos so you can see that it does work. I'll click all the little things you need. Okay, so there's the vertex. Now, that spot is like -28 and -5, so it's like way over here. But the bowl is still going to the right. How I know that? That's a normal graph. It goes to the right. If this was a negative out front, if this was like a negative y squared, all it would do is it would switch it around. So the bowl would be going this way instead of to the right. That's the only difference. My normal graphs go to the right. So now, that means the focus is on the right side of it, and the directrix is on the left side of that coordinate right there. So when we find the focus in directrix, and you're going to the right and left of it, you're affecting this number, not the 5 in the back. Because you have to think about how to go to the right. Well, if I go to the right from -28, I'll be going this direction, so it'll be like -27 or 26 or whatever that number is, right? And if I go to the right, or sorry, left of that, it'll be -28 or -29 or -30 as I go to the left. So the up and down isn't affected, so the -5 won't change when I do the focus and directrix. Now, the distance, whatever this number is out front, you still set it equal to 1/4c. So in my case, I still set it equal, multiply the c across, and so my distance is, on this particular problem, still is 1/4, because if I multiply the c across, 1 times c is still c. So I'm going 1/4 to the right from this thing, and 1/4 to the left going back. So 1/4 this way, 1/4 this way. So the focus, if I go 1/4 over, if I go 1/4, I'll hit -27 and 3/4. That's going to the right. I'm adding 1/4 over. Bless you. And if I go 1/4 back for the directrix, so if I go 1/4 this way from this coordinate, I'll hit x equals -28 and 1/4. And notice it's x equals, because I'm hitting the x-axis only. And so it'll be 1/4 this way, so it's negative 28 1/4. Or negative 28.25 if you want to do the decimal. Questions on Directrix and the differences? We haven't seen that yet, right? We haven't done differences like that. Again, as you guys are writing, so now some of you are still writing, we'll graph this real quick. Shouldn't just shut down my computer. Just left it up there. Let me graph the decimals real quick here. Okay, what is my equation? All right, what is that? X equals, what is that? Y squared plus 10y minus 3. Zoom out here. And x equals negative 28 and 1/4. And what is that other coordinate? Negative 27 and 3/4, comma, negative 5. There you go. Let's pop this up so you guys can see this. There you go. There's your graph. So I just typed in that equation. I didn't modify it at all. Just typed in that so you can see it. Typed in the Directrix. Typed in the focus. You can see kind of what they're looking like. So in the Directrix, I just typed in the x equals, and then for the coordinate, I just typed in this coordinate for the focus, so you can kind of see where those are falling. Notice when you write x equals for the Directrix, it only hits the x-axis. It's going up and down. The parabola itself is going horizontal. So how many times will that function hit the x-axis? That curve? Once. It'll hit it like way over here. So if you need to figure out where it hits the x-axis, you'd have to plug in a 0 for all the y's and solve. So it actually hit at negative 3 down the road. In fact, I'm going to scroll so you can see that. So if I zoom out a little bit, zoom in here. Here's where it's hitting the, right there, there's where it's hitting the x-axis. You can see it's hitting right at negative 3. You can see right, that's right where it's crossing. So again, just knowing how to find these things, the shortcuts for, what do you type in, all that, that's kind of the part that you have to kind of figure out as you go through these units. Like how do I find an x-axis? Well, in this particular case, I'd have to plug in zeros for my y's because that will give me x numbers as opposed to a y-intercept. This thing would hit the y-axis twice because it's a curve, right? Now this graph only hits it once, but if this thing was shifted over and down, it would hit the y-axis twice. So that's something you got to think about. So you'd have to factor it and all that good stuff to figure out where y-intercepts would be. So, all right. But yeah, so this is the first one. Let's do one more and then I'm done for the day. I just want to kind of talk about this. So let me get rid of that. I'll keep the graph up just so we can actually look at it. I'll pull up the next one. I'll give you guys kind of a free play on the numbers involved here. So what number do you want out in front of my y squared? 4. Okay, let's put a 4 there. Okay. So 4y squared. Let's put, I don't know, let's put some number back here. Let's go like 8y and give me another number, positive or negative number.
6. Negative.
Okay, I heard negative and I heard a 6, so I'm going to do that. So, all right, so there's my numbers. Okay, so again, let's kind of walk through the process. We'll graph this one. We'll kind of see it. I'll throw it through decimals again. It's my last problem of the day. Okay, so throwing these things together, I'm going to have to move that 6 across, so it becomes a positive 6. So here's what we have so far. It is definitely horizontal. There's more y's than x's on this particular problem, so it's definitely horizontal. It's going to the right like normal because there's no negative sign out front. So it's not like turned around by any means. So probably hit the y-axis twice, possibly. I do have to factor out the 4 though. So that's kind of a weird number. We haven't had to do that yet. So I'm going to factor out the 4 here. So when I factor out the 4, divide that by 4, divide this by 4. So there's what we have. Yes, you have to divide both by 4 when you pull it out. Don't forget that. Some people forget that in the last test. Factor, you have to divide it out. All right, so now we've done that. All right, we've done all the little things. Now we can complete the square. Half the middle. So it's half this middle. 1 square it. 1. So that's a 1. We have to take it times the number out front. There is a number sitting there. So 1 times 4 is 4, and that's what I'm adding to the other side. Again, it's always half the middle squared times the number out front, and that's what I'm throwing across the other side. So what we're going to have here, we're going to have, what, x plus 10. And then over here, I can factor this thing apart. Half the middle is just a 1. That was half the middle. Okay, so not too bad. So we went pretty quick. Where is my vertex at? Where's the bottom of this bowl? Or not, I guess not the bottom, but the leftmost point of this bowl.
-10, -1.
Yeah, -10, -1. It's the opposite with the x, opposite with the y. Good, good, good. We have to find the focus in Directrix here. But again, that's, so this spot right here is -10, -1, so it's kind of like the last problem I just did a little bit. It's almost the same exact drawing. Let's see. We have to find the distance to the focus and the distance to the Directrix. So whatever number's out front of my parenthesis, I have to set that equal to 1/4c. So I have a 4 here. So it's not going to be as easy as the last one. It's not just a 1/4. In fact, if I multiply the 4c across, I get 16c. And divide by the 16 again. So my c is a 1/16. So I'll multiply the bottom across to get the c off the bottom of the fraction. So I get a 16 over there. So 1/16. So I'm going to go to the right from here, 1/16. So the focus I'm gonna land on, because again it's going to the right. So I was at -10, -1. If I go to the right 1/16, I'm going to hit -9 and 15/16. And if I go to the left, that'll be my Directrix, which is x equals, and that's to the left of this dot, 1/16, so it's -10 and 1/16. So to the right and to the left. And notice the Directrix is always x equals now. So again, how I know I went to the right and left, it's just kind of knowing where the bowl goes. So if the bowl went the other way, I'd have to go to the left to find the focus and to the right to find the Directrix. Just kind of know where the bowl faces. So let's type this in. So turn off all those graphs I just did a little bit ago. What do we got? We have x equals, what is that thing? 4y squared. What do we have? Minus or plus 8y minus 6. We have x equals, what's my Directrix? -10 and 1/16. And my focus, -9 and 15/16, comma, -1. Is that what it is? All right, let's take a look at this thing. Here we go. Graphed it in Desmos. There you go. So you can definitely see it's hitting, it's hitting -10 here. Negative 10. This is -1. It's going down by halves. Then it's over 1/16, back 1/16 for my 2 Directrix and the focus. So there you go. Okay. Google question of the day. They're going to have you do this stuff. Okay, they're gonna give you an equation. Boom, there it is. Like something like that, right? They're gonna ask you to go find the focus, the vertex, and the directrix for your problem. So you have to follow kind of the math I'm doing here. It's the same stuff we've been doing, now you're just doing it for the y's. I want you to get familiar with how the directrix works, how the focus works, all that good stuff. So there you go. Okay. Go to town. Your question went live a few minutes ago. So there you go. I'm going to turn off the camera here.